Hello everyone, I'm back with another video. So let's solve the problem LeetCode 66 plus 1. Let's read the problem statement. You are given a large integer represented as an integer array digits, where each digit of I is the ith digit of the integer. Okay, the digits are ordered from most significant to least significant in left to right order. The large integer does not contain any leading zeros. Okay, increment the large integer by 1 and return the resulting array of digits. Fine. Digits 1 2 3, add 1, it becomes 1 2 4. Okay, 4 3 2 1, add 1, 4 3 2 2. Fine. 9, it becomes 10. Alright, this is a very easy problem. There is nothing much to do about it, just some edge cases. Okay, so let's see. The first example is 4 3 2 and 1. This is an array, right? This is an array. This is an array. We have to add 1. Where do we add 1? Definitely at the last position, right? So it becomes 2. Okay, this one is fine. Let's take another example. What is that? 4 3 2 1, 1 2 3. That would be also same. 1 2 3, add 1, it's 1 1 2 4, right? The third example is 9. If we add 1 to it, it becomes 10. It seems fine, but the problem is that we are given an array of size 1, right? It's an array, not an array list or vector. Okay, so we can't change its size, we can't alter its size, isn't it? So the thing is, when we have a 9, we know that it's going to become a 0 and we are going to have a 1 carry. So our this array size is going to increase. So this is the edge case. So how are we going to handle that? Let's directly start with coding. I will tell everything line by line. Alright, first let's take the length of the array. What is the array? Digits, isn't it? Dot length. Okay, what are we supposed to do? We are supposed to iterate from the last index. For int I equals to n minus 1, that is the last digit. I is supposed to be greater than equals to 0 till the 0th index. We will do I minus minus, isn't it? Now let's see here. We had 4 3 2 1. Now we can add here 1 here, right? It becomes 2, no problem. If it were a 2, we could have added 1, it would have become 3. Similarly for 3 4. But for how long? What is the limit? Say we have 8, we added 1, we got 9. But as soon as we have a 9 and we try to add 1, we will fall into a problem. This will become 0. But what about the carry? Right? What are we going to do? If digits of I is less than 9, what will we do? We will increment that position. What did we do? 4 3 2 1, we are here. If it's less than 9, yes, it's less than 9, we will increment it. Done. And we will return it right away. digits. Fine, because we have incremented this, we have made this to, and this is our answer, right? There is no point in moving further, so we return it right away. Fine. Otherwise say we have 4 3 2 9. Now what? We try to add 1. We saw that it's 9, right? 9 is not smaller than 9. It's not. So what will we do? We will turn this to a 0, right? And we will move up. Try to get it. I will explain once again. 4 3 2 1 9, sorry. We tried to add 1, but okay, it's 0. But what about the 1? Isn't it? So if we see a 9, we will turn this to a 0 and we will continue our iteration. Now I comes here, we will see if this is less than 9. Yes, it's less than 9. We will increment this and we will return it right away. So 4329 plus 1, what is it? 4330, right? Say 4399. We try to add 1. No, it's not smaller. We turn it to 0. We come here. Let's see. Is 9 smaller than 9? No. We again turn it to 0. We come here. We see. Is 3 less than 9? Yes. What will we do? We will turn this to a 4. So 4399 plus 1 is 4344. Definitely. This is our answer. So what will we do? We will do digits of I equals to 0. We will turn this to 0 and our I will decrement and we will go to the second last index. So we are at last index, then at the next iteration we will go to the second last. If we couldn't add 1, we will go to third last, like that. Now what is the edge case? That is the edge case. While what about the case when only thing we have in our array is 9 or no, multiple 9s? Say 9 9 9. What is 999 plus 1? It's 1000, right? But our array size is fixed. So how are we going to turn this to an array of size 4? Let's try to understand from our iteration. 999, right? 999. We are first here. We saw if it's less than 9. No, it's not. Okay, turn this to a 0. Come here. Is it less than 9? No. Let's turn this to a 0. Come here. Is it less than 9? Again no. Let's turn this to a 0. Then we will move out of bounds. And what did we see? We couldn't return any answer, right? Our loop will break. Our loop will break without returning any answer. That means if our loop breaks, if we reach to this position, this certain area, that means that every digit in our digits array was 9s, right? Isn't it? They were all 9s. We tried to add 1 but we couldn't, so and at the end we moved out of bounds. So now we know that our array is nothing but full of 9s. Now what we will do, we'll create a new array, new int. Now what will be the size? 999 plus 1 is 1000. Size 3 increases by 1. Array was 9, becomes 10. Size 2. Say 99,999. It's 1 lakh. Array size becomes 6. Right? Our array size is what? Initial array size is n plus 1. Simple. Now, when we initialize a new array, it is generally by default full of zeros. Okay. We will turn this first 0 to 1. Pretty simple. 999, right? We initialize a new array 0 0 0 0. Turn this to 1, we get 1000. 99,999, a new array of size 6. We are supposed to get 1 lakh, right? Turn the first 0 to 1. We have our answer, 1 lakh. 9, initialize a new array of size 2, 0 0. Our answer is supposed to be 10. Turn the first 0 to 1. We get 10. As simple as that. So what will we do? Answer of 0 equals to 1. Or answer of 0 plus plus, whatever you do, doesn't matter. And then return answer. Let's see. Pretty good. Very nice. So what will be the time complexity? At at worst case, it would be like we traversed our whole array. We traversed our whole array, but we couldn't find a number which is smaller than 9. We had to iterate the whole array of size n, isn't it? So our time complexity is O of n. And what about our space complexity? At worst case, when we iterated through the whole array and we didn't find we we couldn't return our answer, we had to finally create a new array, right, of size n plus 1. So that would be also a space complexity of O of n. N plus 1 is nothing but n only, isn't it? So this is pretty much our solution. Very easy problem. All right, so if you like this video, do make sure you hit the like button, and yeah, definitely subscribe, and I'll see you in the next video. Bye bye.